Welcome to Formula 1 Maths and to past exam questions 002. We've got 3 questions to solve, so let's get started. Question 1. Make F the subject of the formula D is equals to 3 brackets 1 minus F over F minus 4. So the first step would be to move the denominator, F minus 4, to this side of the equation. Remember to put F minus 4 in brackets. So if you do that, you're going to get this. The next step would be to expand the brackets. So if you expand the brackets, you're going to get df minus 4d equals to 3 minus 3f. Then we collect like terms. We bring the 3f over here and take 4d over there. So if you do that, you're going to get this. Because we want f to be the subject, we need to factorize the f out of the brackets to get this. And then we need to move the d plus 3 to that side of the equation so that the f can be by itself on one side. So if you do that, you're going to get this. And this is the final answer for question 1. Question 2. ADC is a triangle. AED and ABC are straight lines. EB is parallel to DC. Angle ABC is equal to 148. Angle ADC equals to 63. Work out the size of angle EAB. You must give a reason for each stage of your working. So I will find this angle here and this angle here first. Then I'm going to take it away from 180 to get angle EAB. But I must give reasons for each stage of my working. So the first one will be angle AEB is equal to 63. So I'm saying that this one is 63. And the reason is because this angle and this angle are corresponding angles. So you have to state that corresponding angles are equal. Then I need to find this angle here. I know that this angle here and the one I'm looking for are on a straight line. But we know that angles on a straight line add up to 180. So if I take 148 from 180, then I'll get 32. And that reason would be angles on a straight line add up to 180. So that is 32. Now I'm going to find this one, which is what we're asked to find. All I do is I add this and that together and take it away from 180 because angles in a triangle add up to 180. So I'll get EAB equals to 85. And the reason would be angles in a triangle add up to 180. But in the exam, please put down some working out. So for example, I would do 180 minus brackets 63 plus 32. And then I can write down my final answer, 85. So that is the answer for question 2. Question 3. The diagram shows 2 shaded shapes, A and B. So we've got A here and B here. Shape A is formed by removing a sector of a circle with radius 3 minus 1, 3 minus 1, from a sector of a circle with radius 5x minus 1. So if I add this one to that, I'll get 5x minus 1. Shape B is a circle of diameter 2 minus 2x centimeters. The area of shape A is equal to the area of shape B. Find the value of x. You must show all your working. First of all, we find the area of circle B. We know the diameter is 2 minus 2x, so we divide it by 2 to get the radius, which is 1 minus x. But we know that the area of a circle is pi r squared. So we can go and write down the area of this one here as area of B to be pi brackets 1 minus x squared. The area of a sector is given by theta over 360 times pi r squared, where r is the radius of the sector and theta is the angle of the sector. In this case, the angle is 45 for both sectors, both the small one here and the big one over there. So let's note that. Now the radius of the big circle will be to add this one into that to get 5x minus 1, and this was stated here. So we can go and write down the area of the big sector. The area of this big sector here is 45 over 360 pi times the radius squared. We can go and reduce this fraction to get 1/8 pi brackets 5x minus 1 all squared. Similarly, we can find the area of a small sector, which will be this. If it is reduced, you get 1/8 pi brackets 3x minus 1 squared. Now, how do we find the area of this shaded part? Shape A, we need to take the area of the small sector from the area of the big sector. So let's go and do that. So area of shape A is all that, and you can see that this is the area of the big sector, and this is the area of the small sector. But I can do some factorization by bringing 1/8 pi out, and I put a square bracket, and on this side, I'm left with 5x minus 1 all squared, minus, on that side, I'm left with 3 minus 1 all squared. I go and further simplify by expanding this one here and this one here. If I expand this, I'll get that. If I expand this, I'll get this one here. Then I'll simplify to get this. Be careful here. So let me show you how we got this from here, this step. 25x squared minus 9x squared. So 25x squared minus 9x squared is equal to 16x squared. Then minus 10x minus 6 will be minus 10x plus 6x. So minus 10x plus 6x will be minus 4x. And that's what we get here. Now, plus 1 minus plus 1 will be 1 minus 1, and we get nothing. So we end up with the area of shape A being this. We are told that shape A, the area of shape A is equal to the area of shape B. So we can go and equate them. Now, before we equate them, we could have factorized the 4 out. So there's a 4 here, I can get a 4 here, and I can get a 4 here. So that can come out to get this. And this will further simplify to give you a half pi brackets 4x squared minus x. So that's the simplified form of shape A. We can now go and equate this simplified form, which is the area of shape A, to the area of shape B, which we know to be this here. So let's go and do that. So we get that. We can simplify this by multiplying both sides of the equation by 2, as I've done here. So this whole side multiplied by 2 and that whole side multiplied by 2 will give us that. So here, the 2 will cancel that, and then I'm left with pi brackets 4x squared minus x equals to pi brackets 1 minus x squared. But I can also divide that side by pi and that side by pi. That means this pi will go. So I'll be left with a very simple equation here. Then I expand this thing here, 1 minus x all squared, to get that. And then I'll open up the brackets to get that. Then I will rearrange to bring like terms together to form a quadratic equation. So plus 2x squared will come over to be minus 2x squared. Minus 4x will come over to be plus 4x. And the 2 comes over to become minus 2. So in the end, we are going to get this. So this is a very nice quadratic equation where the coefficient of x squared is not 1. So let's go and try to solve that. So if I do this, I'll get 2x squared plus 3x minus 2 equals to 0. I want two numbers which multiply to give me minus 4. So 2 times that is minus 4. So the two numbers must multiply to give me minus 4 and add to give me 3. And you can see that it's going to be plus 4 and minus 1. So I'm going to replace the 3x by plus 4x minus x. So I'm going to get 2x remains, but the 3x is replaced by 4x minus x. Then the minus 2 remains equal to 0. If I factorize these two here, I will get 2x out, brackets x plus 2, and then minus 1 out, and I'll get x plus 2 here equals to 0. Then x plus 2, x plus 2 will come out, and I have 2x on this side, and then minus 1 on that side equals to 0. So we get this. And then we solve this to get x equals to minus 2 and x equals to minus a half. But you know that x is a length and x cannot be a negative number. Because if you put a negative number here, you're going to get minus 6, minus 1. And this length cannot be minus 6, minus 1, which would be minus 7. So the correct answer is a half. So that's question 3. That's the end of PEQ002. Thank you for watching, and I'll see you in the next video.